Welcome back to SoftwareDude. In software development, particularly in the context of web and database driven applications, how data is loaded can significantly impact performance, experience, and resource utilization. Two primary strategies for data loading are eager loading and lazy loading. This presentation, we will cover the concepts, benefits, drawbacks, and trade-offs primarily uh, between the lazy loading and eager loading strategies of any kind of application. So let's start with lazy loading. In this approach, data is loaded on demand, right? Only when it is actually needed. This can help in deferring the loading of certain pieces of data until they are required, potentially improving the initial load times. One of the use cases that you might see in social media platforms is that it's continuous scrolling, right? That's kind of a lazy loading. It's not like the entire news feed is being pulled in one request, right? So it's paginated, but it's also in the form of continuous loading, which is in the form of lazy loading. Now, what are the benefits? Faster initial load. Only the data that is immediately required is loaded, right? Leading to a faster initial response time. Only the data that is accessible is loaded, which can help in conserving memory, and on-demand loading, which is flexibility to load the data only when it is needed, right? Which can optimize resource usage. Drawbacks: increased query count. Each on-demand data fetch results in additional database queries, right, which can lead to performance overhead. Complex code, because handling lazy loading can complicate the code base. It is at times not very easy, although there are several programming languages out there and techniques out there and libraries out there which have now made this much more easier because of the recent need of these lazy loading kind of applications, right? So that it provides a much better user experience in terms of fluid user experience, but it can complicate the code base as it requires mechanism to load the data on demand, right? And then there is potential latency, because accessing data is that is not preloaded can introduce latency, but particularly if it involves remote data fetching, right? So these are some of the drawbacks. Now let's look at eager loading. Eager loading in this strategy involves loading all necessary data upfront in a single query, right? Or at the beginning of a process, or at the beginning of a page load, right? It is often used to reduce the number of database queries by retrieving all the related entities in one go. Like in the image that I am showing here, you will see that in one call you are getting the data for graphs of different types, right? But in the client side, the only bar graph is only required, right? The line graph or the pie charts are not shown, but it is, while it is querying, it is getting the entire data upfront, which is eager loading, right? Now let's look at some of the benefits. It is reduced query count. By retrieving all the required data in one go, the number of database queries is minimized, right? In this case, if you look at the image, you will see that there could have been potentially 3 database calls, but or like 3 server calls, but this was done with only one call because we fetched all the data together, right? Consistency, right? All related data is available immediately, ensuring data consistency within the context of that transaction, right? And then it is simplified code, because you no need to write additional code to handle on-demand data fetching, right? So those are the benefits, but there are some drawbacks. The first one is the high initial load time, right? Because fetching all data upfront can lead to longer initial load times, right? Especially if the data set is large. Increased memory usage, similar reason, but loading all the related data at once can consume more memory because you are loading more data, so it can consume more memory. And then potential overfetching, like in the example that I've shown here, you might end up loading more data than actually is necessary, right? Which leads to inefficiencies in the systems. Now let's look at the trade-offs between lazy loading and eager loading. First is performance. we discussed the lazy loading is faster initial load. It increases the number of queries, but for each query, I think the initial load is much faster. Eager loading is it reduces the number of queries, but longer initial load time, right? Because you are fetching all the data at once, so your number of queries to the backend is less, but you will have to pay the cost of performance in terms of more initial load time. So if there are cases where you are using backend systems which can charge you per call or per transaction or per request, then in that case, eager loading from a cost analysis standpoint can be much more beneficial. We'll look at that. Memory usage, like we discussed in the lazy loading, it is lower memory usage, loads data on demand. But in eager loading, it is high memory usage because you are loading a higher volume of data at one time, right? Complexity, it is much more complex code base, requires on demand data loading logic, though I did mention that there are some languages and libraries which have now been introduced which does this very seamlessly, but still there is a learning curve. Eager loading, simpler code base, I mean it's just a query call that you would anyways do, so there is nothing much to code more, right? In cases of implementing eager loading, there is definitely no demand for on demand, like no need for on demand loading logic. Consistency, potential inconsistency if the data changes between loads for lazy loading, because depending on, because there will not only, so your loading is basically a get query, right? A get scenario, a read scenario, but it can be depending on how write heavy your system is, right? The view of the system, because you are loading data in chunks, the view of the system can lack consistency, right? But in eager loading, it will ensure data consistency in a single transaction, because you are having only one query to load the entire data, right? In that sense, I also have made a system design trade-off video between different types of consistency models, like strong consistency and eventual consistency. I link that video in the description of this video. Should look at different types of consistency levels, but lazy loading and eager loading also kind of ties hand in hand with that kind of a concept, where in case of lazy loading, there can be potential inconsistencies, but in cases of eager loading, data consistency will be much more strong, right? Because it is only in a single transaction. Next is flexibility. Lazy loading is much more flexible because you can load the data as needed, so it's more flexible also for the user, for the client, but also and also for the for your front end, so to speak, right? But in eager loading, it is less flexible because you have to load the entire data in one go, right? Which can also make it over complicated in terms of designing the backend systems, because here you might go out of track to design one API which can respond the entire data, right? It's not use case based, or it's not fine grained in that sense, right? So if you have overloaded logic to entire respond back with entire data sets, huge amount of data sets, then your API design might not be right? It should be entity based, it should be very singular responsibility focused, not like a broad level query which can send you all types of data and metadata together. But that is where it is eager loading is less flexible. And next is latency, obviously, like potential latency during lazy loading, because when accessing unloaded data, so because you are loading the page, either the page or every time you are scrolling, or every time only on demand of the request you are accessing the data, right? So there can be latency not only while calling the system, but also latency can be observed by your user, right, by the customer, because while they want to go to the next page of data, or want to see the next set of data, at that point of time your front end is going to make a request to the back end, and you will probably have some kind of a loaders or the images that will probably keep them busy. But that is also where the latency is introduced, because it takes time to get the data from the backend. But in cases of eager loading, because you are loading the entire data up front, you are already populating the entire page with all the data that a user needs to see, there is no requirement of another load, which means that there is no additional latency, because the entire data was fetched in the initial load, right? So no additional latency for eager loading, right? So depending on what is your application requirements, it primarily depends on that. But lazy loading and eager loading are two strategies in which you can build more sophisticated web applications or user interfaces which primarily interact with backend systems, right? So that was the system design trade-off between lazy loading and eager loading. Hopefully this was useful. Thanks for watching.